This is Mr. Bell's coming at you. We're going to talk today about geometry, Geo A, specifically section 4-2 on reflection images. Again, we talked a lot about translations in 4.1 and gave an intro to some of the other stuff. So a reflection image is like my hands right here. You can see that if I took one and flipped it over this vertical line in between them, it would show up directly on top of the other one, okay? So that they would have opposite orientations. And here we go. I'm going to use the student journal for a lot of this stuff. Hopefully that you guys can have that out and take notes in that, and it will be beneficial. Here we go. Awesome. So first thing we want to talk about in this thing is exactly what is a reflection. And I'm going to kind of show you here that if I had, and I'm going to do it this way, if I had a flag like this and I'm reflecting it over this line, this kind of diagonal line, its end result would look like this. And if it was perfect, you would see, and it's not perfect, but it's pretty close. You would see that these two segments right here would be congruent because they have to be the same distance apart, and that those two segments right there would be congruent, and they would also be perpendicular to this line. So my flag's a little bit off, but it's pretty close. So what is a line of reflection? A line of reflection is that line in the middle that you can flip one image over that line to the other one so that all their points line up exactly as it is. Now, glide reflections we talked about are things like this, where I don't have a specific line per se that I can flip it over, but I could flip this over here to this, just like that, and then translate it. So a glide reflection has a reflection followed by a translation, and you can see it would look just like this. So this would be image 1, image 2, image 3 as we go through the thing. Good deal. Line of symmetry, if I have a shape, let's go ahead and do an isosceles trapezoid like this. If I have a shape like that, something has a line of symmetry if you can put a line through it and then fold it perfectly so that one half would line up directly on the other half. And again, this was supposed to be, if I do this like this, make it look like that and make that congruent and these congruent. You can see that that definitely is a shape that has line symmetry. Okay, so line symmetry means that a shape can have a line going through it, splits it into two equal parts. A line of symmetry actually is that line. So shapes can have line symmetry. So for instance, the capital letter T, block style like this, assuming that I do it nicely, has a line of symmetry that goes right here. Okay? It doesn't have a horizontal one or anything like that. But if I had a square, watch this one, the square. I'm going to call it a square. So this has a line of symmetry that goes like this. It has a line of symmetry that goes like this. And I would tell you this, this will come up later too, but if you have at least two lines of symmetry that intersect, then it also has what we call rotational symmetry. But a square also has a line of symmetry that goes like this, and a line of symmetry that goes like that. Good deal? So how do we know how to do a reflection? So I'm going to go through a little bit of this stuff, but not a ton. So if P is reflected over this line to P prime, two things are going to happen. One, the distance from P to the line and from P prime to the line has to be the same. That's why those two things are congruent. And two, if I drew in this segment right here, this segment has to be perpendicular, which means line M is the perpendicular bisector of segment P to P prime. Okay? And we'll do different constructions and reflections and stuff like that. So let's talk about coordinatized stuff. So we said in when we were doing translations, right, that we could take any xy, we could translate it into an x plus 2, comma, like a y minus 4, that's how it would change. So, and then in class the other day, we talked about reflections. I tried to do as much stuff as I could on that day. But if you're brand new to this stuff, I'm going to go through each one of them. If AB is reflected in the x-axis, then its image is at point A, negative B. So what does that mean? So if I have a point here, let's call this 1, 2, 1, 2. Let's call it 2, 3. 2, comma 3, because I don't want to use the same numbers for them. Let's say that's 2, 3. If I then change the point to 2, comma negative 3, 2, comma negative 3, you can see that's down there. That's a reflection over the x-axis, okay? So in the x-axis or over the x-axis, however you want to say it, is fine. Now, if I did negative A, comma B, that would be negative 2, comma 3, right? And negative 2, comma 3 is over here. And that would be a reflection over the y-axis. So an A negative B flips it over the x, and negative AB flips it over the y. And this one right here, so if I went from, let's get brand new points here. Let's go 7, 2, 1, 2, 3, 4, 5, 6, 7, 1, 2, 7, 2. And then I just switch these and make this new point 2, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. Like that. 3, 4, 5, 6, 7. You can see that those are actually reflections. Oops, sorry. That goes right through the origin. Over the y equals x line. And this is the y equals x line, because that's where x and y are the same. So at 1, 1, at 2, 2, at 3, 3, at 4, 4, at 5, 5, at 6, 6, at 7, 7. That's when y and x are the same values. So that's a reflection over that. And then our next one, if I change their locations and change their signs. So if 2, 7 was my original one, or sorry, this was 7, 2 for my second ones. 7, 2. Now this one's saying, hey, I'm going to switch the A and the B's locations, and I'm going to make them both negative. So now negative 2, negative 7 would put it right down here, and you could see that that's actually a reflection over that line, which is the y equals negative x line. And here is my original, right? Let's call it point Q, just because Q. So this was the first one. That got me to a Q prime. And then from here, when I did negative B, negative A, that flips it over to here. Give me a Q, different prime. Not the same ones. But I don't want to use a prime here and a double prime here, because that technically kind of means that this one's moved to that location. Just say that's another point. Okay? So this says in exercise 1 through 4, graph triangle ABC and its image after reflection in a given line. So what I'm going to do is, this says in the y-axis. So I look up here and I go y-axis, y-axis. That changes the A, but not the B. So then I'm going to plot 1, 5, because that changed the A. I'm going to plot 4, 4, and then I'm going to plot 3, 1. That's what it should be if I'm going to flip it over the y-axis. So let's check. So negative 1, 5, negative 1, 1, 2, 3, 4. Oop. I can do this. Hopefully you can do this with me. We're going to call that 5. We're going to make all these intervals 2. And we're going to be okay with that. So, oops, sorry. And if all these intervals are 2, I got to put it there. Don't put it there. And then negative 4, 4. So negative 4 and 4. There's another point. And then negative 3 and 1. So negative 3 and 1 right there. So those are my locations. And I'm going to do 1, 5. So 1 and 5. Look at that. And 4 and 4. Look at that, and 3 and 1, 3 and 1. And you can see that, look at that. This triangle is reflected over the y-axis. So changing the x, leaving the y the same, reflects it over the y-axis. And you can practice on any of these ones right here. I'm going to do this one right down here to make sure that you can see how this works out. So This time it says we're going to reflect it over the line x equals -3. So before I do that, I'm going to plot my points. Okay, so -2, 3. This time I'm going to actually do it, yeah, I can do it this way. I'm going to treat each box as 1, and I might have to extend my box. That's okay. So -2, 3, there's A, and -2, -2, -2, -2, there's B, and C is 0, -2, there's that one. So that's triangle ABC. And it says we're going to reflect it in the line x equals -3. Well, where's the line x equals -3? That's that line right there. So if I'm going to reflect it in that one, then A is going to go right to there because it's one box over, one box over. B is going to go right to there, one box over, one box over. And then C is 1, 2, 3. So 1, 2, 3 boxes over. And you can see that this will be A prime, this will be B prime, and this will be C prime. So hopefully, hopefully that all makes sense, just like that. I'll pause it on the video, or you can stop it on the video so you can see it now. Looks like I missed part of the description on that. Okay. So these next things kind of say, hey, can we do this? So it says, graph a polygon's image after reflection in a given line. So y equals x. Y equals x is this line right here, right? So I'm hoping it makes sense that this box is going to go down to here. But if you need to, just flip back to this, and you can see reflection over y equals x line switches the A and the B. Okay? So we want to graph y comma x from my original point. So if D is at -3, 4, if D was -3, 4, then D prime is going to be 4, -3. You see how we're doing that? We're just switching the x and the y spots. 4 and -3 goes right there. And we can do that for all of them, but if that's in that top corner, I think this will be pretty okay, right? We can see how this kind of goes. I'll go ahead and do C so you can see it a little bit easier. C is at 1, 4, so then this one's got to be at 4, 1. Okay? And then if this one's at -1, oops, sorry, 4, -1. So if this one's at -1, 2, this one's at 2, -1, and you can see that all of those points go just like that. Is that good? Awesome. If y equals -x, if y equals -x, if we're reflecting it over this line, that's this one, right? Then we look back over here and we go, hey, what do I do with it? Not only do I switch the A and the B's places, but I also make them opposites. So let's go ahead and write C originally. So C originally is at 2 and looks like 5, 2 comma 5. So C prime, we said if we're doing y equals -x, we're going to switch their places, right, and make them opposites. So -5, -2, -5, -2, and that's my C prime. And you're going to do that for all the rest of those points and fill those in, and hopefully it's all good. So what do exercises 7 and 8 do? 7 and 8 are taking it a step further. They're saying, hey, we're going to do a composition of transformation. So we're going to do one thing and then another. So let's go ahead and put this in. So I'm going to put in JKL originally on this one, and you can do the other ones as you see fit. So JKL, 3, 1, so 3 and 1, and 4 and 2, and 1 and 3. Cool. It's a little harder on these tiny little graphs, but they're trying to save some space. If you want to do any of this work on a separate piece of graph paper, you can just print some off the internet, print some separate little ones, and use those. It'll be good. Okay, so now this says it's a translation first, and the x is going to go -6, and the y is going to go -1. So that means left 6 and down 1. So if I was going to do this, my j prime went from 3 right up here, right? If I take 6 away from that, now it's going to go to -3. And from 1, I take that away, it's going to go to 0. So -3, 0. -3, 0. That's going to be right there. Remember, that's what this point was before. Now it's new images right there. In fact, I'll go ahead and put that on there. So there's J, and then this one was K, and then this one was L. So there's my new one. Now J prime, let's go K prime. So K prime is at 4, 2, so that's going to be -2, because 6 away from 4 is -2. And 1 away from 2 is 1, so -2, 1, -2, 1. And you can see that. And then I'll do the last one here, L prime. L prime is 1, 3, 1, 3. Sorry, that's originally 1, 3. I need to subtract 6 from it, so -5. Look at how I made that work out perfect. And 3 minus 1 is 2. So -5, 2. So -5 and 2. And you can see that that looks like a translation. But now we're going to take this one right here, which is what we have in these locations, and we're going to reflect it in the y equals -x line. So we're going to do a composition. So we're going to do one and then the other. So I'm going to do that in red right here, and I'll just kind of put it down that you remember y equals -x becomes a -b comma -a. So j double prime, right, means that I'm going to do this right here, -3, 0 becomes, they both become opposite and they switch places, so it becomes 0, 3. K double prime becomes, they get switched their places, and the -2 becomes +2, but the +1 becomes -1. And L prime switch their places, and the -5 becomes +5, and the +2 becomes -2. Okay, so now I'm going to plot these. So 0, 3, 0, 3, like that, and then -1, 2, -1, 2, like that, and then -2, 5, -2, 5, like that. And you can see that my first thing translated over, my second thing reflected over that line. And that's what we call a glide reflection. So it's going to have a translation and it's going to have a reflection. And I could have done it either way. This is kind of weird, but I could have done the reflection first from this one over to here and then slid it up, and it would have been in the same spot for it. Was you good? Awesome. You could do one for the line x is equal to 1. I'm not going to do that. We're going to talk real quick about this. So it says identify the lines of symmetry, if any, for the word, the whole word. Okay. So moon, nothing. Like if I put this here, the M would flip over onto an N, and those aren't the same thing, so I cannot do that. However, wow, if you look at this one, if I put a line right there, the W flips over onto the W, the O flips over on the O, and we are all good. We're like, hey, what about this one? What about this one? If I put it there, the K would flip over on the D, and you're like, no, there's nothing. But wait, what about that line right there? The top of the K flips to the bottom of the K, the top of the I flips to the bottom of the I, and the top of the D flips to the bottom of the D, and now that one actually does have it. And then I look over here at this one, I'm like, hey, I think all of those ones have that line of symmetry, that horizontal line of symmetry. So hopefully this is good. You kind of have an idea of what we're talking about for reflections. And the next thing will be rotations, and we'll come to that in just a little bit. So this is Mr. Bellis. Hopefully that was beneficial and you understood those. Practice some of those ones. Make sure you do the ones in the online homework, and I will talk to you